Welcome to another deep dive. Today we're plunging into something, well, foundational really. It's about trusting the AI systems that are increasingly, woven into our lives.
Right.
We're talking about securing the data that powers artificial intelligence. Often overlooked, but absolutely critical.
It's where the AI gets its smarts, isn't it? But it's
Yeah.
also where the weaknesses lie. If you can mess with the data, well, you can mess with the AI's whole picture of reality.
Exactly. And we're looking at some pretty serious guidance today. The source is a joint cybersecurity information sheet. It's from a real heavy-hitting group,
Oh, yeah.
the NSA, CISA, FBI, plus their counterparts in Australia, New Zealand, and the UK. Big coalition.
Wow. Okay, so international effort.
And it's marked TLP clear. That basically means they want this information out there. They want everyone, informed.
That TLP clear marking,
Yeah,
that's a big signal. They're saying, look, this is important and everyone needs to know about it. It suggests a sense of urgency.
definitely. So our mission in this deep dive is basically to give you a shortcut to understanding what these experts are saying. We'll unpack the key risks they see for AI data. Its integrity, its security.
And the fixes, right, the practical stuff.
Exactly. We'll walk through the best practices they're recommending to actually, fight back against those risks.
So think of this as getting the condensed version, the briefing on a threat landscape that's, well, changing really fast, filtered by top security minds.
And why should you, listening right now, care about this? Well, AI is doing more and more. Little conveniences, sure, but also big decisions. Critical stuff. And whether that AI is reliable or fair or even safe. It all comes down to the quality and the security of its data. Understanding these risks, that's how you know if you can trust an AI. Or maybe when you should be asking some harder questions.
Yeah, it gives you the tools, the language to really judge AI's trustworthiness from the ground up.
Okay, let's get into this guidance then. The absolute core idea they keep hitting is, it sounds simple, but it's huge. Data security isn't just something you tack on at the end.
Right, not an afterthought.
It's fundamental. It runs through the entire AI supply chain. From the second data is thought of or collected, all the way through how the AI runs.
And they define data security pretty broadly, drawing on things like the IC data management lexicon. Basically, it's protecting data from anyone doing anything unauthorized, seeing it, using it, changing it, destroying it.
Comprehensive.
Totally, keeping it safe from any angle.
And why is nailing that security at every single step so vital for AI?
Because the AI models, the machine learning,
Yeah.
they build their entire logic, their decision-making, from the data they chew on. So if someone manipulates that data, even in subtle ways, they can directly twist the AI's behavior, its outputs, how it thinks. You poison the well, essentially.
Right. The AI learns the wrong things. The report kind of frames this across the whole AI lifecycle, like the NIST AI risk management framework does.
Yeah, it walks the stages, plan and design, collect and process data, build and use model, all the way to operate and monitor.
Okay.
And for each stage, they flag the key data security points. So early on, plan and design, it's about thinking security from day one, privacy by design, secure architecture, that sort of thing.
Makes sense. Build it in, don't bolt it on.
Exactly. Then, when you collect and process data, the big focus is integrity, proving the data hasn't been tampered with. Authenticity, encryption, strong access controls, who gets to touch what.
And when you actually start building the model.
For build and use model, the critical bit is protecting the data while it's being used for training. That means securing the training environment itself, making sure the data quality is sound, maybe using privacy techniques like processing in secure enclaves or adding noise to protect individual data points, stuff like that.
Okay, so it's like securing the ingredients in the kitchen where you're cooking.
Yeah, that's a good way to put it. Then verify and validate. This is all about rigorous testing. Security testing, checking data integrity again, maybe even adversarial testing, deliberately attacking it to see if it holds up.
Or break it.
Right. And a really crucial point they make here. This verification isn't just once, it's every single time you feed new data or user feedback back into the loop. And that new data, it needs the exact same high security standards as the original stuff. No shortcuts.
That feels really important. It's ongoing, not a one-and-done check.
Absolutely. Then as you deploy and use the AI, you need secure infrastructure. Think zero trust networks trust nothing by default. Secure data transport, secure storage, monitoring for weird activity.
And finally,
Operate and monitor. That's continuous risk assessments, having incident response plans ready, securely deleting data when it's time, and just generally staying on top of compliance and threats.
So if you drop the ball at any of these points, what are the consequences?
Well, the report lists them out clearly. Corrupted data, models that are wrong or even malicious, sensitive data getting leaked, failing to meet regulations, it all tracks back to insecure data.
Okay, that definitely sets the stage. Now, the report gets really practical. It lays out 10 specific best practices. Like, these are the concrete actions these agencies want people taking.
Yeah, these are the essentials, the building blocks. Let's run through them.
Okay.
1. Source reliable data and track data provenance. Know where your data came from. Keep a solid, verifiable log of its journey. They even suggest using a secure, cryptographically signed database just for this provenance, something immutable.
Why is that so important?
So you can trace things back if something goes wrong. Spot potential data poisoning. Prove the data hasn't been secretly messed with along the way.
Got it. Number 2.
2. Verify and maintain data integrity during storage and transport. Use checksums, cryptographic hashes, basically give the data a unique fingerprint.
Right, we touched on that.
Yeah, if even one bit changes, the fingerprint changes. It's an immediate red flag for corruption or tampering, whether the data is just sitting there or moving around.
Okay, 3.
3. Employ digital signatures to authenticate trusted data revisions. You sign the original data, then you sign any approved changes. Using trusted certificate authorities adds weight. This confirms not just that the data is intact, but that any changes were deliberate and authorized. Helps you prove exactly what data went into training or fine-tuning.
So it's like signing off on official documents, but for data sets. And they mentioned thinking about quantum computing.
They did adopt quantum-resistant standards. It shows they're looking ahead, planning for when current encryption might be breakable.
Okay. 4.
4. Leverage trusted infrastructure. Build your systems using things like zero-trust architecture. Maybe use secure enclaves, special hardware or software zones that protect data while it's being processed.
Like a secure computation bubble?
Sort of. It isolates sensitive operations, makes tampering much harder, protects data integrity during computation. 5. Classify data and use access controls. Simple idea. Not all data needs the same level of protection. Categorize it based on sensitivity, then apply the right controls. Maybe super strong encryption for the really sensitive stuff, less for public info.
Makes sense. Tailor the security.
Exactly. And they make a key point. AI output should generally be classified at the same level as the most sensitive input data used to create it.
Ah, interesting rule of thumb. Okay, 6.
6. Encrypt data. Non-negotiable, really. Strong encryption for data at rest when it's stored and in transit when it's moving. They recommend standards like AES 256 for storage and processing, and TLS, ideally with AES 256 or even post-quantum algorithms, for transit.
Just scrambling it unless you have the key.
Pretty much. Security proportional to sensitivity.
7.
7. Store data securely. This gets into the hardware. Use storage devices that are specifically certified for security, like meeting NIST FIPS 140 standards. These certifications mean the crypto parts inside are properly designed and vetted.
So not just any old hard drive.
Right. Choose storage that provides the hardware-level security you need.
8. This one sounds interesting.
8. Leverage privacy-preserving techniques. This is huge when dealing with sensitive stuff like personal data. They list a few key techniques.
Like what?
Data depersonalization or masking. You swap out real sensitive details for realistic fakes, but keep the overall statistical patterns. Lets you train models without exposing actual PII, for example.
Okay.
Then there's differential privacy. It adds carefully calculated statistical noise to datasets or query results. Gives you a mathematical guarantee of privacy, though there's often a trade-off. More privacy means potentially less accuracy for the AI task.
A balancing act.
It is. And finally, decentralized or federated learning. Instead of pooling all the data in one place, you train models on multiple separate local data sets. Then an aggregator combines the learnings, often using secure computation methods, so no single party sees all the raw data.
So you can learn from scattered sensitive data without ever bringing it all together in one vulnerable spot.
Exactly. Limits the exposure points dramatically.
Okay, almost there. 9.
9. Delete data securely. When you're done with data, especially sensitive AI training data, just hitting delete isn't enough. File systems often just mark space as available.
Right, can often be recovered.
Easily. So you need proper methods, cryptographic erase, block erase, overwriting multiple times, even physical destruction for drives following standards like NIST SP 888, Make it truly irrecoverable.
Essential before getting rid of old hardware. Got it. And finally, 10.
10. Conduct ongoing data security risk assessments. The threats are always changing. So regularly use frameworks like NISTs to check your security posture, find new risks, figure out what to fix first, and just keep improving. It's continuous adaptation.
Okay, that's a really solid list of operational practices, but the report goes deeper, right? It highlights 3 specific areas where the risks are particularly significant, even if you're doing those 10 things.
Yeah, this is where they really dig into the persistent challenges. The first big one is the data supply chain.
This is about data coming from outside, or even moving inside your organization, being bad from the start, malicious, or just wrong.
Exactly. And they really focus on the vulnerability of data consumers' organizations using data sets they didn't create themselves. The warning is stark. You just cannot assume that big data sets you grab off the web or get from a third party are clean.
Because if you train on poisoned data,
your model learns the poison. It inherits the flaws, the biases, the vulnerabilities.
So what can you do as a consumer of data? What do they suggest?
Several things. First, verify data sets before you even ingest them. Scan for malicious stuff, inaccuracies, then look for content credentials, metadata that's securely attached, tracking origin and edits.
Like a history log for the data?
Sort of, but they caution. It provides context, not necessarily truth. You still need to verify the content itself. Also, ask for assurances from foundation model providers about their training data. Get formal certification from dataset providers if you can. And finally, use secure storage once you have the data. Maybe an append-only, cryptographically signed database. Check the signature every time you access it.
They get really specific about web-scale data sets, too. That split-view poisoning thing sounded kind of scary.
It is, because it's practical and surprisingly cheap. They point to curated web-scale datasets, things like LAION, COIO, which are often just lists of URLs pointing to content online.
Right.
The risk is those URLs can change, domains expire, someone else buys them, and replaces the original image or text with something malicious.
And the cost you mentioned.
Yeah, that's the kicker. The report says effective poisoning might cost as little as $1,000, maybe even just $60 in some cases.
$60?
Yes.
To potentially compromise a major AI training data set.
Wow.
It makes it a viable attack for almost anyone, not just sophisticated state actors.
So how do you defend against that? Curators need to attach hashes, those digital fingerprints of the original content. Then consumers verify the hash when they download. Curators should also periodically recheck the links, remove or verify changed content, and certify they're doing this.
What about data that's more dynamic, like, say, using Wikipedia snapshots?
Right. Collected web-scale data sets, they're vulnerable to front-running poisoning because snapshots are often predictable.
You know when they're going to take the picture.
Exactly. So an attacker slips in malicious edits right before the snapshot, hoping they get captured before human editors catch and revert them. The report mentions analysis suggesting maybe up to 6.5% of Wikipedia could be vulnerable to this.
That's a lot of potential bad data making its way in. Mitigations.
Consumers should ideally test and verify the datasets themselves, or only use snapshots from really trusted parties. The collectors, like Wikipedia, can try to randomize snapshot times, make them less predictable, maybe freeze edits for review before a snapshot, but relying only on humans to catch subtle edits is tough.
And the Wild West. Just crawling the web directly.
Web-crawled datasets, highest risk. No curators, no original hashes, no trust signals on updates. The suggestion there is consensus maybe only trust data that appears consistently on multiple independent sites, or frankly, organizations need to do their own massive curation effort, or just avoid these datasets if they can't build trust.
So the big takeaway on supply chain is buyer beware. Don't just download and trust.
Absolutely. The report is blunt. Split view and front running are real, practical, low sophistication threats. You have to think about data poisoning as a supply chain problem. Pick your providers carefully. Demand evidence they're filtering bad stuff and tracking quality.
Okay, so that's bad data coming in. What about data getting messed with after you have it, or having flaws that weren't deliberate attacks? That's the second risk area, right? Maliciously modified data.
Yeah, this covers deliberate manipulation to mess with accuracy or security, but also folds in the impact of just plain errors or accidental duplicates.
What are the main types of risks here?
Yeah.
And the suggested fixes?
A big category is adversarial machine learning, or AML. These are deliberate attacks, things like data poisoning again, but maybe targeting specific outcomes. Adversarial examples crafting inputs that look normal to humans but fool the AI. Think stickers on a stop sign making a self-driving car see a speed limit sign.
Yikes.
Yeah. Or model inversion attacks trying to extract sensitive training data just by probing the model.
Actively trying to make the AI fail or spill its guts.
Pretty much. Mitigations include things like anomaly detection systems, regular data sanitization, filtering, normalizing data, securing the training pipelines themselves, maybe using ensemble methods, combining predictions from multiple models, or data anonymization.
They also mention bad data statements. What's that?
That's about problems with the metadata, the data about the data. If it's missing or wrong, it causes integrity issues, makes the model perform badly. The fix is better metadata management and governance, validating it, maybe enriching it to fill gaps.
And then there's the elephant in the room.
Yep. Statistical bias. The report defines it as the AI behaving in systematically inaccurate ways because the training data wasn't representative or had weird artifacts. They even nod to the U.S. executive order demanding government AI be free from ideological bias.
How do you fight that?
Regular audits of training data, making sure it's truly representative of the world the AI will operate in, identifying and mitigating edge cases where the data might be thin, and then actively testing for bias in the model's outputs and trying to correct for it, maybe even keeping a library of known biases to help unlearn them.
Trying to actively counterbalance detected bias. Interesting.
It's an ongoing challenge.
Yeah.
They also talk about data poisoning via inaccurate information, basically, disinformation deliberately inserted. Mitigations include removing it if you find it, using provenance and verification, cross-checking sources, fact-checking, maybe adding more good data during training to overwhelm the bad examples, and general data quality control.
And even just accidental data duplications.
Yeah, unintended copies or near copies can skew training, cause overfitting, where the model gets too tuned to the training set and fails on new data. Standard fix there is data deduplication techniques.
Okay, so that covers deliberate attacks and inherent flaws. The third big risk area feels different. Data drift.
It is different. Data drift isn't usually malicious. It's the natural, usually slow change in the real-world data the AI sees after deployment compared to the data it was trained on.
So the world changes, and the AI's training data gets stale.
Essentially, yes. The statistical properties of the input data shift over time. Performance degrades.
So if poisoning is someone swapping ingredients, drift is like the climate changing slowly outside the kitchen, affecting how the bread rises.
That's a great analogy. Poisoning is often sudden, dramatic. Drift is typically gradual. Monitoring helps tell them apart.
What causes this drift?
All sorts of things. Changes in upstream data sources like sensors getting upgraded, new kinds of data start appearing that the model never saw in training, or just changes in the context a company merger changes the user base, for example.
The operational reality diverges from the training snapshot, and spotting this is crucial, especially for critical applications.
Absolutely. Think healthcare, an AI diagnosing conditions. If the patient population changes or testing methods evolve, undetected drift could lead to wrong diagnoses. Early detection is vital.
How do you tackle drift?
Need a good data management strategy to track changes. Use data quality testing tools. Critically, you need rigorous input and output monitoring of the live AI. Are its predictions still accurate? Does the live data distribution still look like the training data distribution?
Constant vigilance.
Yes. Continuous monitoring. Regular retraining on fresh data. Ongoing data cleansing. Maybe using ensemble models, which can sometimes be more robust to shifts. The report does note this is still an active research area, but the key is building the monitoring and mitigation frameworks in from the start.
Wow. Okay, this has been a really comprehensive deep dive into what feels like a hidden but absolutely vital part of AI.
It really highlights how crucial, secure, trustworthy data is. You can't have reliable AI without it, especially as we depend on these systems more and more.
We've covered a lot. The need for data security through the whole AI lifecycle, those 10 specific best practices from the international agencies, and then drilling down into the big risks.
Yeah.
The supply chain nightmares like split view poisoning.
Yeah, the $60 attack.
Right. And maliciously modified data, and that steady creeping challenge of data drift.
And it's clear this isn't a problem you solve once, it's constant work. Vigilance, adaptation.
Which brings it back to you, listening. Think about the AI you use daily. Smart assistants, recommendation engines, maybe tools at work. Why should you worry about data provenance or digital signatures or where web scrape data came from?
Because the AI's decisions, the information it gives you, it's basic reliability. It all depends on the integrity of that underlying data.
Understanding these issues gives you power. Power to ask better questions, to demand better assurances.
To be a more informed user,
Yeah.
definitely.
So here's the thought to leave you with. Given everything we've discussed, the supply chain vulnerabilities, the potential for manipulation, the inevitability of drift, how can we as individuals and organizations really build and maintain trust in AI systems over the long haul? Especially as they get embedded in more critical parts of our lives.
Yeah.
What level of transparency, what kind of verifiable proof about the data should you start demanding from the people building and deploying these AI systems? Something to mull over until our next deep dive.